Welcome back. I enjoyed my lunch, I hope you did. To the last afternoon. I think the last thing we did, we created DTMs, and there should be, well, for me, they are in the DTM folder. Now you may have noticed it created KML files. I should maybe stop it from creating KML files, because these KML files don't really mean very much, as the TIFF you generate don't look very interesting in most image viewers like this, because they contain elevation values and not colors. And when you use an image viewer, it expects an image to contain colors. This, however, contains numbers, with decimal points that express the elevation at every pixel. These can be loaded into QGIS or ArcGIS and turn into an elevation model. That's what they are. So loading these ones into Google Maps will not show you much except sort of an outline of where you have numbers in white and in black where you don't have numbers, because those are all zeros. But before we load them into a software, let's also create the DSMs. And maybe you still have LastToDem open. I don't. I think I closed it. So I go back to the binary folder and look for LastToDem. So you need to keep in mind, we didn't clean the high noise points. So there will be a little bit of noise because I saw a few birds or some other things flying very high. I omitted this step because I had already told you how to use last noise. And I didn't want to do a second run. We're not going to use anything special because the noise is we only have the noise under the ground. We can't use it because the noise above the ground we didn't properly re-noise to only get the very large noise points. If you look at the other folders, can we use?
We could use ground. We could use. We could use ground.
Ground we could use, yeah. Normalized?
No.
Certainly not, because we don't have any more elevations, and the DSM should give us the elevations at every point. How about denoised? Yeah, because how about raw?
Yeah, actually we could use raw.
Yes, because all we're going to filter on is the first return. And the first return is already in the raw data. If we do not filter out the high noise, which we didn't. So we will expect a little bit of high noise in our output. But for this exercise, that's fine. In practice, you should do one more processing step with any of those and filter out the high noise. We'll use the same step size. We again produce actual values. This time I don't want to forget to run on as many cores as I have available. The output I want to put now in the other directory, the directory called tiles DSM. Again, I want to use, let me close this. Again, I want to use TIFF as the output format. And again, very important, use the tile bounding box. Why is it important now? Well, A, it's important, otherwise I get rasters that are too big, that have a border of 25 meters around them. But you can say, oh, we didn't really do any processing that could have produced artifacts. Well, generating a tin and then rasterizing the tin will also create artifacts if you stop right at the corners of the tin, of the boundary. You should have a few more points on the outside so the triangles along the boundary are not long and skinny, which you have maybe seen sometimes in some previous processing if you've ever done it. We want there to be points, so the triangles across the tile boundary look just normal, get rasterized all the way to the edge, and the bad triangles are far away from that boundary that we rasterize. So use tile bounding box is important for two things. We cut down the tile to the area we want, and we still triangulate the whole thing, but we only raster the inside. So we create a much larger triangulation, much larger, 25 meter larger in all directions, than we actually rasterize afterwards. And rasterizing, I don't know if you know that term, it means just I have this tin, and then I go with sort of a stencil over the tin, and every grid point I go down until I hit the tin, and I record the elevation. Clack, 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 that's rasterizing. I just sample the elevation of the tin at that point. One more important thing I shouldn't forget is I'm filtering based on first only returns. So I only want to keep the first return. This usually gives me a nicer looking DSM. It doesn't really give me a beautiful DSM yet. And maybe if you have time, we can talk about some strategies to create even nicer DSMs. For the CHM, I will spend more time on that because the CHMs are usually more important to you than the DSMs being in forestry. Okay, so let me have a look what I have now as a command line. I think everything is done.
What about the projection?
The projection should already be there. Yeah. So course 7, first only, elevation, I use the tile bounding box. So the important part is this one here now. I use only the first returns and I raster only the tile. And the output goes there into the directory, and I'm running on 7 cores. Looks good to me. I think that concludes the use of LastToDem for the time being. Let's just use one tile, just so I told you about it. It's called LasToISO, but I think it cannot clip to the tile boundaries yet. You have to see it. So LasToISO. That goes from last files to ISO contour lines, which the contour lines are often called. And let's load in the ground classified tiles. So anything last ground or higher, except not normalized. So I'm loading the ground classified tiles. And you all know contours, right? If you look at the map, a topographic map, there are contours on there. And these contours are called cartographic contours. They're usually created by a cartographer who is somewhat of an artist, because he has to take accurate geographical information and present it in a visual, pleasing way. And that's sort of where, where science meets art, because the visual pleasing way is not always a scientific way. Because if you be accurate, then it's often not visual pleasing. So I create accurate isocontours, which are not always visual pleasing. We can do some smoothing, but the smoothing goes slowly away from the truth. However, some smoothing is usually okay, otherwise they just look too jagged. So there's an option to smooth the tin before you extract the ISO line. So the ISO contours are extracted from the triangulation. Then there are some default options of cleaning short segments or simplifying short segments or removing very short lines, which may be just sort of little bumps in the road. And then we can output it in shape format or in KML format. Since we want to load it afterwards into QGIS or ArcGIS, let's use a shape format. One option is still missing here is use tile bounding box. So right now our ISO contours will be a little bit too long. There's one tool which avoids the whole problem. It's called Blast to ISO, where you just can use all the points and create one gigantic ISO contouring and optionally tiled as output. But I don't want to use that. I'll just want to give you a feel for what you can get with the contouring. So I'm running now the separate tiles, and they will have overlaps. So I'll just tell you that ahead of time, so they won't be perfect. So contour lines, just thinking about as a deliverable for contour lines are not for the computer to use. Computers don't use contour lines. I mean, they hate contour lines, actually. A contour line is just for the human to look at, because it's very easy to understand what the terrain does if you look at the spacing and the density of contour lines. When they come very close to each other, we know there's a steepness. The steepness can either go up or down, that you get out of the context usually, or the shading of the map. But there's no reason to create a contour map for later to have the computer perform some kind of operation on it. What we can do here, we can specify how we want our contour lines. We want our contour lines every n units, so that would be, in this case, every 10 meters. Or we can specify a single ISO line if you only want the ISO line along the ocean, only the one at level 0, assuming we have a geoid heights where 0 actually means where the water is. So let's go to every n units, and then how frequent do we want our ISO lines? Every 2 meters? Maybe? It's too detailed?
That's normal.
That's normal. Every 2 meters. I don't know what's normal. Every 2 meters.
Should we have a filter for the ground?
Somebody's thinking, not me apparently, but at least somebody. Yeah, we of course need to filter the ground points. So let's keep classification. I don't need to say it anymore. Let's keep the ground points. And say, what do we say? Run. Core 7, keep classification 2, every 2, smooth it in, simplify something, clean lines that are 5 meters or shorter, and output it in shape format. Oh, we haven't said where. So let's go back and specify an output folder, which we don't have yet, so let's create an output folder. So, output folder, tiles, whatever, contours. And again, I must warn you, these contours will have overlap because I don't cut off the overlap right now. I usually use Blast to ISO, the other tool, but for that I first need to remove the buffers, and I don't want to do this right now. Okay, now I can add the output directory. Tiles contours, use current, and I'm starting it again. And now my command line should be complete. There's my output directory. Okay, I'm starting it. Let's have a look what was generated there. I have a lot of files here. I look at one of them. I have something installed here called Shape Viewer. I think you don't. I like that program. It's a very simple viewer. You don't have to open ArcGIS to quickly inspect some shape files. That's how it looks like. Okay. I don't know yet if that's good or bad, but it doesn't look absolutely horrible. Let's look at another one. Okay, that looks pretty. Later in ArcGIS, what means later, very soon now, basically now, we will load these all on top of each other. Let's use ArcGIS. My arc map is here, and I still use 9.3. I just have this empty canvas. So let's drag and drop these tiles on here. The DTM tiles. I'm taking all the TIFF files now. Maybe some of you have already done it. And I drag and drop them here. Oh. Then it looks like this. Beautiful. I want the color ramp to go from, I don't know, -2 meters to plus 20 meters in a grayscale. And I don't know how to do this. Table of content. Ah, okay. Oh yeah, that's what I wanted. Oh, there we go. And now I set minimum scale, or?
Yeah, it's also very old ArcGIS, so it's not like that anymore.
Oh, that's just installed it.
No, that's one, because that is
Set maximum scale.
Is this 10 point something?
Oh, but where do I do this now?
because that's the map Martin uses.
There's a function
Ah, okay.
compute
Yeah, he's not using
new
ours,
value
sorry.
something.
Yeah?
But actually, I really don't remember how to look in that.
Data, maybe here. Data.
Well, properties down there.
Oh, properties. Yeah, go. Ah, yeah, that's how it used to be.
I think it's symbology.
And I can say color ramp. Oh yeah, here.
Unique values in the top.
I can just say maximum. Let's say 20 meters.
Yeah.
Oh, that's a-
you go to unique values. No, back to symbology. Yep. And then the menu left, in the left side.
Okay, here.
Unique values. Yes. I think that might work. And then you select the color scheme. The color scheme just above. Yeah. Choose and go down. Then you will have some nice ones. Yep.
Is this one?
And apply. Or okay.
Oh, I see. Stretch type. Ah, yeah, there we go. That's the one. Custom. I want to go to custom. Then I look at the histogram, and I see they're going from 37 to 49. So now I know 35 to 55. That's what I want, roughly, for all data sets. Can I now not say it here? 55 and then 35 and say OK? No. I want the all right, so I'm dragging and dropping. Well, it's a bit nicer initial experience, but I still don't have them all in the same scale. I have the feeling ArcGIS changed my data set. You see, I was doing some operation on it, and I think it actually changed it on file.
It's not like group selected, but on a raster in the menu in the top.
Uh-huh.
And then miscellaneous and build virtual raster catalog. and use visible rasters for inputs. And just choose an output file.
Hello.
And okay. And then close. It's perfect. Yeah, press close. Otherwise, and then remove the original. Just move the whole.
Uh-oh.
Yeah. This is correct. It's just the minimum and maximum. Now right click and properties. And try press load in the right side.
In Max?
Yeah, and then just press load.
Load.
Maybe use actual for accuracy.
Right.
And load again. No? Okay, then you no, there it is. Okay.
Okay. Then apply.
And then you can change the color from.
So now you have a seamless raster.
Yay! Look at me. I did that with open source software and some help from the audience. Okay, now I'm dragging in there my contours. And each got a different color, so it looks prettier.
If you merge them into one, you could also
Have one color, but it looks so pretty with a different color. Yeah, so these are imperfect, as you see. I should have cut them off. So because we have the buffer, we have these kind of little edge effects. And this is exactly where they overlap. You see the blue one and the violet one, they're overlapping here. So in a future version of LasTools, I will cut them off right here, and then they'll align perfectly. That's not done yet. Also here you see these colors in the overlap. And then these are the edge effects I talk about. When this one gets to the very edge, suddenly you have these funny things. And if you cut them off in the middle, then you have nicely looking contours coming from both sides. And that's why you use buffers. Here you see it nicely using the contours. Okay, so now we have open QGIS. Why not take a quick look? And you don't have that right now because, well, you may have it, but the version you have won't work. So I'm working right now on a toolbox for QGIS, or it's more or less done. It's been around since QGIS 1.8, but it's getting more and more interesting. You may have it, but it won't work because you have to install a few things. You don't have it if you use the simplified interface. You only have it if you use the advanced interface. And how do you get this box? This box you get if you start the processing toolbox. Either way, so what you can see that all the LasTools you've been using so far, they're all here. And you can access them, last to them, we used it several times. And you get a beautiful little toolbox, which has more or less the same options as a GUI, a few less options, but the options you most commonly will use. And so this has been around for a while, but this one only allows you one single input and output file. Now that's interesting to get started and work on a small set of data, but if you want to do the kind of production workflow we did today, where you start with flight lines and you operate on entire folders of files, you need something that I call LasTools production. And right now there are only 3, and they probably don't work correctly yet because those are the ones I'm working on right now. And now instead of having an input file, you have an input directory. So all the files in that directory will be used that match this wildcard, and you can change the wildcard accordingly. You can filter a little bit and so on. So once you have these, you should be able to use the model builder to use these and connect them together and build entire pipelines. Now, I haven't really learned how to use a model builder in QGIS yet, and I'm really looking forward to the next 2 days and learn more about it when Victor is here, who is the brain behind this entire framework that allows to integrate other programs into QGIS in this very seamless fashion. So, but I have already started to do something I can do, and that is create pipelines that do not use the model builder. And here's one like this. It is a pipeline that goes from the original flight lines to DTMs and DSMs in basically one click. You just input the directory with the flight lines, and then behind the scene it will tile, it will buffer, it will ground classify, it will DTM and DSM and so on. And because all the source code is available, you can basically create similar toolboxes then. Imagine you are the GIS guy in your organization. You know how to create these because you just copy and paste my example. It's not rocket science. But then you modify the workflows to better fit your organization's needs. And then you can give that toolbox to the 10 other people, which are also GIS people, but they don't know how to write Python scripts. They know how to use toolboxes, but they don't know how to use LasTools. But you do. So you are the one guy that basically creates toolboxes that then can be used by many others for much easier LiDAR processing. And that's sort of what I hope to achieve with these toolboxes in QGIS. And of course, if somebody is a model builder user, and we learn about it, I don't know if you're all here tomorrow and the next day, but then you can connect together different of these toolboxes into a longer workflow and basically create, in a visual manner, create these pipelines. And now that I've, given a big break to QGIS, I would like to go back to ArcGIS, because also I sometimes like to trash talk Esri a little bit, and with very good reason, and they know why. I still support ArcGIS and have some very interesting additions that you also already have in your LasTools distribution right now. So in your ArcGIS version, and it would be great if you could open ArcGIS, you should have a way to open the toolboxes that you have available. And for me, this is, I click on this button here, show. It looks like a toolbox. This one here. Here are my toolboxes. So now what I will do, I will delete my toolboxes because you don't have them yet, and I want to get on the same level where you are. Remove. 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 So maybe your toolboxes look something like this. Maybe you have a few more, a few less. We want now to add the ArcGIS toolboxes here. And in this step, it is very important, and I'd like to go back to the toolboxes which are in this folder. It's important to read the Readme when you do that at home, where it says a few things. You need to leave the toolbox inside the LasTools folder. Don't move it anywhere, because if you move it, it cannot find the LasTools anymore. And another thing, it's very important that there's no space or any funny characters in the paths. That's why I asked you to put it in a very simple path on the C drive. So if your LasTools folder is somewhere like this, you know, your path to LasTools looks like this, that's okay. But if there are spaces in the path, or spaces in the path like this, or there is, you know, even worse, you have a bracket in your, or equally worse, you have a bracket in your file folder name, that's not okay. The toolbox will not work under these conditions, and this has to do with the Python scripts that work behind in the scene will not work. LasTools will work, but the Python scripts will not manage to call LasTools. So it's a very simple thing. That's important. So if you have ArcGIS open now and you right click, at least for me, I don't know how it is for you, when you right click on the Arc toolbox, then you have this option of adding a toolbox. And if you say add a toolbox, then I don't know how long it's going to take for you, but for me it takes a long time. And eventually I get to add a toolbox. So I go to where my LasTools distribution is, and I look inside the ArcGIS Toolbox, and now I have one of 4 toolboxes to choose from. Or maybe just use the basic one, LasTools. Now don't click twice. At least for me, it doesn't work anymore. Only click gently once. So the LasTools is written down here. And then you say open. And then the LasTools toolbox shows up here in your toolbox. And all of a sudden, just like in QGIS, all the LasTools are available inside ArcGIS. For example, LastToDem. And now we have ArcGIS Toolbox. The description looks a little funny because I edited this once with ArcGIS 10.0, and then I saved it to 9.3, and then I opened it in 9.3, and then everything blew up in my face, and I don't know how to fix it. But you can still read the important parts. This is just a formatting issue here. And maybe it looks nicer in your version. I don't know. In my version, it looks like this. It's fairly well documented. If you go in the different entry, it tells you what all these are for. The LastTools.tbx, that's the one I loaded. But there are 4 toolboxes. So I want you to load another one, namely the LastTools production. So I'm adding the LastTools production. Now I'm adding the LastTools pipelines. And then, why is there pipelines twice? Well, once the pipelines is implemented, that's what I did first with the model builder, but that doesn't work across all versions. And since I only have one version and I can't re-implement it on all different versions, I just re-implemented them also as toolboxes instead of the model builder. Okay, so we have the production tools, and like in QGIS, they are already completed. All the tools are here. They work on folders of files. So if I look at last ground, for example, double-clicking last ground, it tells me, you know, input folder, input wildcard, the very usual things you used to. You fill this out. Interesting thing here, if you know anything you want to do that is not in the menu, but you know the command line because you've seen it so many times in the GUI, you can just add that command line here. For example, if you want to add a UTM, you know, if you want to add also, at the same time, I want to add this a projection to the output because it's still missing. You could just add that there. But of course, you got to be careful here. If you make a mistake, it will fail the execution. More interesting are these, and I can show you these in a visual representation. So these pipelines, if you look at them, for you, most of them will have a black cross through them. And that's the incompatibility between different ArcGIS versions. Now that's not very nice for the user because I don't want to have to rebuild them on every different platform. So I created them, and for me, you see they all look beautiful. And it's the exact same file you opened, but in a newer version of ArcGIS, and it stops working. For example, a quality report now. Look, it's very simple now, a raw flight line quality report. I remember we did that yesterday. So here I just, as input folder, or maybe we can just, oh, you can't do that. Well, we do it with the other one, not with the model builder. So this is how the model works behind the scenes. You see I have the input folder. That is then going to the overlap computation, the several grid computations, the boundary computation, and the info computation. And then I say which step size I want, and this all goes in there. And this creates the overlap raster, an expected density raster, the boundary polygon, and the LastInfo report. And so it basically starts all these tools one after the other to, with just one toolbox, create a lot of outputs. And because that's something I do every time I get a new folder of LAS files, I don't have to go through all these steps. Of course, I could also write a batch script, and that would be maybe my preferred way of working. But with LasTools, you can really choose what you want to do. You want to use them as ArcGIS Toolbox, QGIS Toolbox, through the GUI, through the command line, or you want to write a batch script. Some people even can, for example, the people in Stanford that have the airborne platform and scanning all the forests in Panama to estimate the biomass. The guy working there, he wrote a program that calls LasTools with system calls. So he has his own language to call LasTools. Let's look at one more. Raw flight lines to DTM and DSM. You do know this pipeline now. How does it look as a model? Well, exactly as you would expect it to. We start with an input folder that goes into last tile production. It needs a tile size, a buffer size, and it doesn't need any more. And then it outputs into the temp directory. That's where all the tiles go. Now last ground, it needs a terrain type and takes the input from here, needs to know how many cores it should run on, and puts the output back here. Then last to dem starts to create the DTM, and last to dem starts again to create a DSM. They all need to know which step size to work with, on how many cores to run, and they put the final output here. So if you now look at the corresponding toolbox, it's very simple, and it does all these steps behind the scene. All you need to give it here the raw flight lines. Of course, that sounds really simple. Nah, that doesn't work with our data because nobody did the noise removal, right? This pipeline will not work on our data because we also need a noise removal step in there. But of course, you could write a pipeline that has this noise removal step built in by adding yet another module. But for the end user, the user that you would be serving by creating such a toolbox, all they would have to do is fill out three things here. Input folder, output directory, this one, and then say which tile size and buffer they need. Because the pipelines in the model builder don't work very well across platforms, I created, basically last week, I started creating the same pipelines with scripts, with Python scripts. Now I don't have this nice visual representation, but I have tools that function across different platforms. And for example, what I would like you to try, maybe make a quality report right now. So we run this pipeline. You're really part of my, because I just finished this last week, you're sort of part of my, my quality assurance team to make sure before I advertise this that I have a new toolbox that avoids the model builder, that it works well. So let's try, select an input folder, and let's use our Denmark data set. The 4 flight lines, the original raw flight line. We haven't touched them in a long time. They are under LasTools, bin, Kalundborg, strips raw. That's it. Oh, I need to go up one directory, at least me. Select it and then say add. Then the step size, yeah, I'll leave it at 1 meter. And I need an output directory. So let's create a temporary output directory for this particular quality report. I'm going back to my Explorer window and create a folder that we don't have yet because we didn't do a quality check. Remember, I said we wouldn't do one, and now I'm doing one anyways, but we're doing it a completely different way now. So I create a folder called quality. Quality. And in that folder, we will now put all the outputs of the toolbox. So the output directory of this toolbox, don't listen to what the toolbox says. I still need to fix that. But the description is still a bit messed up. So the vertical difference I set to 30 centimeters. We talked about this yesterday. The expected number of pulses per area. We have a step size of 1. We expect, what was it, 6. So let's say we said we want 4. Let's just say that. And when do we consider it excessive? When it's, I don't know, when it's, maybe let's put it a bit higher. When it's 12 pulses per square meter, we consider it excessive, and we don't want too many of those. And that's it. That's all we have to do, I hope. And now I press OK. And now I see the output as it's working. First, it starts LastValidate. That's a tool that validates if the input is correct. And you see what the LasTools toolbox does in ArcGIS. It does nothing else but generate command lines. You see the command line here. We haven't used this tool, LastValidate. And that was the validate. It's finished. Next time, LastInfo. You see now LastInfo is running. Minus CD. You see it's going to play some music. It does exactly the commands we've been doing all along, but now it's a Python script in ArcGIS that's generating these commands and not the GUI. There's only one way of using LasTools, is to create a command line that does something. How you create this command line is up to you. In ArcGIS, a Python script will create it. In QGIS, a Python script will create it. You can create it yourself by typing it. The GUI can create it, or you can write your own Python scripts to create it. Or somebody even wrote a C program to create them. So we already did the first outputs for the expected density. And now we already add last boundary when we make a boundary around the output. So now you say, why didn't you give that us in the beginning? You know, that was really easy. Put in 2 folder names and adjust 1 parameter and press run. Well, I wanted to give you enough information so you could actually build a Python script like that yourself once you learned about Python. Tomorrow, I think you will learn about Python, but what you learn tomorrow, you could apply as much back to writing ArcGIS scripts as you can use it in QGIS. Completed script, success, everything done. It took 2 minutes and 20 seconds. So of course, I didn't use anything of ArcGIS in this whole process, except the toolbox that created one command line string, which was then handed to my Python script, and everything else was LasTools and my Python script. Let's see what we did create. I go into the quality folder and voila. Let's do something funny now. Let's double click on one of those KML files. That's going to be funny. You know why it's going to be funny? Because we're going to find out where Denmark would be if it was in the southern hemisphere. Because we didn't overwrite. We didn't overwrite it this time. I mean, the images are still correct, but the PNG, the KML files are useless. So you can delete the KML files. There is no Denmark on the southern hemisphere, as you can see. I don't see anything.
Zoom out.
Yeah, there it is. Wow, look, the water is moving. And so this is now the expected density, and I see it red almost everywhere. Okay, that's nice. I mean, I just put in a value without thinking too much about it. The excessive density, I don't want to see too much red now. Oh, that's good. Not too much excessive anywhere. There you see the difference image. Whoop, it's very sensitive, the control in this area of the world. Like I'm just tip, tip. It's almost impossible to navigate, looks like. There we go. So I set it to 30 centimeters. So this looks like very fine, very nice work. It's very well aligned. There's a toolbox called Raw Flight Lines to Single CHM. No, that won't work. That won't work because we don't do the noise removal, at least not with the Denmark data. But we can use a different data set because we have the Area 0 data set, and there we won't have this noise problem. So let's do it with that data set. Raw flight lines to single CHM. And so that is the algorithm that was presented at Sylvie Laser last year by Khosravipur et al. And it's implemented using LasTools with the concept of partial CHMs. And maybe after the coffee break, I'll tell you a bit more about that. I think it's a really neat little way. And this is actually an enhanced version of this algorithm, also using point splatting. Okay, let's just follow along for the time being. This time we take Area 0, strips raw. Oh, I always go one too deep. Add. No, strips raw. Add. Okay, the tile size I leave. The buffer size, maybe make it 50 meters. The terrain type, there are some really big things in there. So pick Metropolis. It's the airport, remember, and there are some hangars. They're like IKEA sized. The laser beam width means if I create a CHM and I interpolate, and now we're interpolating, why should I interpolate points? When the laser hits the tree, it ain't a point, it's a beam, and the beam has a width. So why should you just use the very center and make an interpolation? So instead I thought, I replace the points with little disks. And here you specify the diameter of these disks. Now you should be a bit conservative. If you make this too big, then you will sort of wash out the detail in your canopy. But making it 0 is certainly over-conservative. So maybe if you have a beam width of 30 centimeters, take 20 centimeters or something, but not 0, I think. This is something I haven't really investigated yet. One student I'm working with, she is right now investigating how much this improves CHM generation, this kind of replacing points with disks, or in computer graphics we call this splatting. You know, you make the point fat, you splat the point. The output I want to, you know, at 1 meter resolution. I'm running this on 6 cores. You should run on 2 cores. Now I need an empty temporary directory where all the temp files will be put. And I just realized I can also create a directory here. So I call this chicken poop. Okay, this is, I know there's nothing really important in there. And the output file I call, so this will be one file. So this program merges all the rasters in the end into one file. And I call it chm.tiff, and I put it into the same directory as, oops. Huh? Oh, I think I'm in the wrong, oh yeah, that's why. In the same directory as area 0. I press run. And it starts. So the first thing it does, it's tiling. And we know that, you know, it's the usual thing. It takes the strips raw, all LAS files and all LAZ files it finds into that directory are used. Makes a buffer of 50 and puts it into the chicken poop. With this name, temp tiles raw flight lines to single pit free.lats. No input specified. Oh, I changed it and I didn't change it everywhere. I changed this to tile, but here it's still called temp tile raw. Okay, now we're gonna do something. We're gonna learn a little bit Python programming, just a tiny little bit, tiny little bit. Okay, so you just close this, and you now go here, and you right-click. And now you're not going to be really, really, really careful because we're programming now. And we say edit. And there's a lot of information in this. This is a script, the Python script that runs under the hood. And now I want you to go down to the right place and change somewhere a name. You only have to change one name and save it again. And it's right here where you have to change it. This long thing was the culprit. Yeah. So we want to change this into tile. You can search for it. Temp tile raw flight lines. It's about 3 screens down. This one here. I think this is the only thing that needs changing.
What should it be changed to?
Tile. Tile.laz. And now let me see if I really do get that right. Because later it will use that as input, you see? And I changed, at one point I changed my mind, name it differently. Now let me just make sure I don't use that anywhere else. So I'm looking for temp something. Temp dir, okay, temp dir I still use. Temp something. Temp dir is fine. Temp, okay. Temp. temp, temp. Okay, looks good. I think that's the only change we need. And now you press Control and S. After you made that one very, very simple change, and you didn't change anything else, I hope. Control and S. And then you just exit this editor by pressing the close. It might be a good idea, however, to clean out the chicken poop. And you know what I mean. I go into the Area 0 directory, because there are already some files in here, and it says it wants an empty directory. So I make this directory empty. I don't know how you call yours, but it asks for an empty directory. So I made this directory, which is for temporary files, I made it empty. Now, instead of having to enter all the parameters again, you can actually, at least for my version, I can go to Results, and I go to Current Session. I don't know how that looks for you. And you see this one failed. So I can just double click it, and it comes back up, and everything is already pre-filled. The same it was last time. Metropolis, strips raw, Area 0, Area 0 chicken poop, or whatever you called it, and the output TIFF. Oh, now last ground works. You see? It stopped there before. But now it found, you see, that's what you changed. Before, for the output, it said a very long word here, and you changed that. Now it says tile.laz, and because you said that, it now finds the input here. All right, and now I replace Z. I normalize the files. And here is where I do the splatting. Subcircle 0.1. That means I'm using a circle with a radius of 10 centimeters around every point. And I'm also thinning it at the same. I'm thinning and splatting to create a. I do a height filtering. I keep the highest point on a grid that is much finer than the final grid, but I replace every point by a disk. So I'm getting rid of all the low points, hopefully not all of them, but a lot of them. And what I do then, I'm creating what I call partial CHMs. And partial CHMs are CHMs that the first one, it's a totally normal CHM. It's computed from all the points. It's like a DSM. I use all the points and compute a CHM. Now next, this one, next one now. The CHM2, I throw away all the points that are 2 meters or lower and create what I call a partial CHM. Now I only make a CHM of whichever is in the forest, 2 meters and higher. And then I throw away everything. I put a triangle monster. I think we talked about those before. And I eat away everything until I'm very close to the real trees. And then I do the same thing again. I throw away everything that's 5 meters and below. And all the points that are high are now used. And as you can imagine, the higher I go, the more defined the crowns are getting, and the more the triangle monster eats away. But the pits, the points that create these spikes downwards, they don't exist anymore because I don't use points from further down. So in the end, you have a layer of CHMs. First the whole thing, and then for every tree that's tall, you have multiple layers of CHMs where the higher layer never uses points that are really far down in the tree. This way, and then I interpolate with all the points, with the true points, but I don't use the bad points that make these spikes. And then I combine them into one, and then I get this CHM without pits. And they look really beautiful. And well, look, it cleaned out the chicken poops. Here, clean up command line. In 3 minutes, we turned this entire 7 flight strips now in a CHM. And let's see what we generated. So we did that in Arc, but I think for the exploration of the CHM, I somehow feel like I want to go back to QGIS. And now I could again need some help with coloring that nicely, because I had this great support just earlier how to turn this into a nice
Double-click in the layer.
visualization. First of all, I want to center it.
You can way zoom.
I can actually do that. That's fine. And now I'm zooming in on some forested area. And you don't see any pits at all in this area. I mean, occasionally you do see a pit, but that's when you actually do have a pit. But there's none of these really deep down black dots in the middle of the CHM. And you can do this for very high resolution CHM also. I mean, I did it now for 1 meter, but the same holds true for half a meter. Or if you have very high resolution, it's a very beautiful looking CHM. And maybe if I can somehow color it a bit more.
Double-click in the layer.
Oops. Double click in the layer.
Yeah, over in the layer. Left,
Maybe.
left, left,
Left,
left.
left, left, right. Right or left? There's a left button. Oh, in the layer. I thought this is the layer. And then I say what?
Properties. And you go from single band gray up, here. And you go to single band soda color. And you can choose another spectrum from green to darker green. Up or down. Choose one.
Well, yeah.
Let's choose the
Maybe this one here. Just a very colorful one.
And if you invert it, then the green will be the lowest and red will be the highest.
Okay.
And then classify.
And then the min I can put to 0. And the max I can put on 23 meters. And then I can say OK. Do we have a more? One with more or continuous? That's continuous, yeah? Okay. I say OK. Ah, beautiful. Yeah, so now I created a CHM. Would be interesting to see the difference to only create a standard interpolation. You see that little airplanes? We're on an airport. And here, these are the big so you see, that was now created with one script that did the whole work in 3 minutes, and I didn't need to know anything about LasTools. All I needed to know is the input folder, what a few of the parameters meant, and create the output folder. And I think with that image, we can now go into the coffee break.